Come on in.
Have a seat.
Hey, how you doing today? Good job.
When I first heard 3D, I was like, it'll probably be really hard, or like bubble letters. But when I saw this, I was like, whoa.
Look at that.
Wow.
Oh, look at it, just popped in.
Yeah,
So
wow.
I love how you added those clouds.
We think that if we can enable the creation of 3D content easily for people, that we can unlock a whole new ability for the way that they can create and for the way that they can learn new things.
It's a lot more accessible and it feels more modern. You don't have to be an expert, because literally in like 5 minutes or less, I was just making whatever I wanted.
Other 3D programs have like giant toolbars at the top, and it's hard to find just one thing to do. This, you just click on the object and all of the options just pop up instantly.
You're able to mix 2D images with 3D images. So I took a picture of myself, like a little selfie, and I put my face behind it, so it looks like I'm floating in outer space.
I really loved the magic selection tool, which I could use to take a photo from real life and put it into my art.
In that playful nature of creating, they're learning at the same time. Creativity leads to learning, leads to innovation.
So in the remix exercise, we each had our own surface with paint on it. We passed it on every 5 minutes.
I started off with this really cool robot three-dimensional object, and it became this flying bunny character, and I thought it was super cool.
Today I was working on the Statue of Liberty with clouds and an airplane and New York City behind it.
I actually have the Megalodon tooth, and I scanned and actually imported it into the drawing.
I always wanted to work in 3D, and now I can.
3D is for everybody.
One word to describe this experience:
Intuitive.
Simple.
Inspirational.
Empowering.
Dynamic.
epic.
Kind of mind blown, I guess.
I'd say it's revolutionary.
Okay, so I'm going to stand here for 2 minutes until we're ready to go. Coming in. I presume you can hear me since I can hear myself, right? All good? Excellent. How many of you were here last year and saw me present about HoloLens? Ooh, that's too many. So remember what happened last year at the beginning? And you all hated me for it? Well, I have one here today. For those of you who didn't understand that reference, I had the bag up front, and I reached in there and took out my clicker, and people went, "Oh, you." So, yeah, none of that. So that means some of you have seen me present before. For those of you that haven't, cool. That means I can use all the same old jokes. If you have seen me before, well, grin and bear it. So we're going to do a little bit about HoloLens development, and this is an introductory session. It's going to be very high level. I did a Twitter poll. I said, do you guys, for the demo, do you want to see the app work, or do you want to see the code for the app? And the overwhelming response was, you want to see the app work. Okay? So there's a short demo in here. It'll be mostly focused on the app. Now, since we're all friends, very close friends, you're not going to tell on me. We are not supposed to stream live stuff to the screen, so you don't get seasick, basically, with me doing this a lot. But we'll do the best we can, all right? So, a little bit about me. I've been in Microsoft for about 10 years, a little over 10 years. Started out in security, kind of a hacker for the good guys, which was kind of fun, kind of weird. Became a technical evangelist, which is probably one of the coolest titles I've ever had in my life. And then now I'm the HoloLens guy. I've been the HoloLens guy for a while now, and I cover Asia, Pacific, and Japan, which means I basically live in the Qantas Club. But, you know, it's been fun. Do you guys travel a lot? You guys have some of those friends that you only see in the Qantas Club or some other country? I know 3 guys I'm based in Canberra, Australia. I know 3 guys out of Canberra that I see more in Tokyo, Singapore, and Hong Kong than I do at home. It's just weird. So, we're at the point where we're going to be, doing development for this device. And today we're going to talk a bit about what is mixed reality and what does that mean, so we have some context. Because it's not VR and it's more than AR, and we need to kind of set that scene, okay? I'm going to give you a quick overview of the hardware. If you were here last time, it's not as in-depth as that one, but you do need to understand how the sensors work, where the sensors are, how this thing kind of operates, all right? And then we're going to talk about building apps for Windows Holographic. Because Windows Holographic is this underlying piece that runs all of these holographic applications, right? The HoloLens is a product that runs Windows 10 with Windows Holographic. Now, how many of you stayed up till 3 a.m. last night and watched the announcements? That's what I thought. That's why I played those videos, because I wasn't up either. But we have announced that we're sharing Windows Holographic with our OEM and ODM partners. They're already making devices for it. Windows Holographic supports everything from virtual reality to almost physical reality. And our partners are also getting in on this. We'll talk a bit more about that when we get into the actual hardware. Okay? So how many of you have not heard of HoloLens? Good. You wouldn't be here if you hadn't, right? Okay, so let's define mixed reality a little bit. We have two worlds, right? We have this physical universe made up of elements and things that we can touch, and we have a digital universe that's made up of digital logic and rules and things like that. And each of those have a corresponding reality. Now, on one side, we have the physical reality. That's what we're in right now, what we're sitting in. On the other end of this, we have virtual reality, which is entirely fabricated, entirely digital. Okay? Everything in between those two is mixed reality. All right? So Windows Holographic is designed to bring mixed reality to life, to let you code for mixed reality. Now, one of the easiest ways to describe this is to kind of compare it to VR. So if you think about virtual reality as taking a person out of the world they are in and putting them into a digital world entirely of your creation, mixed reality is bringing the digital assets out of the digital world and putting them into our physical space, on the podium, the stage, the chairs, hanging in the walls, or even floating beside us in our physical space. Now, I've recognized a couple faces in here. How many of you have tried HoloLens? Cool, so that kind of resonates with you guys. There's still 2 more chances to win a date with me and a 20-minute chance of the HoloLens tomorrow. So if you want to get in on that, yeah, just go to the HoloLens booth where that great big screen is, scan your badge, and you'll get into the drawing for that, okay? So when we think about this, we have these kind of quadrants, right, this diagram, where on one side of this we have desktop-style performance, which requires a massive machine to run. And that's fine, and there are going to be some things that are extremely high fidelity or do a lot of calculations that you're going to need that for. But on the other end, we've got portability, where we're able to move around the building, where we're able to take things and work in different spaces. Now, some of these are opaque devices. Opaque devices are suited for virtual reality because they're designed to remove you from this one. So you've got the 2 little screens, and then we black out everything else. That's virtual reality, so you just focus on the content. The other devices are see-through, transparent, which means you can still stay engaged in the world around you. You can still see your desk and use your PC and talk to people and walk around the building, okay? We can see where HoloLens fits in this, right? So HoloLens was designed for that entire continuum between physical and virtual reality. All of these things can be done with HoloLens. Now, when we think of AR, augmented reality, it overlays information on the real world, and it supplies information to you. It enhances what you're doing. But AR is a subset of MR, right? Now, we didn't coin the term MR. That was actually done in some research papers quite a while ago, but it's very applicable. With mixed reality, we want to blend holograms in your real world. We want to bring that digital asset into your real physical space. So mixed reality does everything AR does and more, right? It can transport you to a virtual world. If you've gotten a hold of a HoloLens and you've tried the HoloTour application, you can visit Rome. It's a combination of 360-degree video and holograms that let you experience a different location. But HoloLens is not designed to replace the real world. It's not meant to remove you from this environment. It needs to do that because we want you to continue to be able to interact with it. So we leave that to VR. Now, VR and HoloLens are not a competitor. Different tool, different job, right? So there may be some times when VR is more appropriate for something you're trying to accomplish, okay? So a bit about the device. Actually, I'm just thinking, these are hour-long sessions, aren't they? 60 minutes? This is a 90-minute session. Okay. And I'm the only thing between you and the party, right? Okay, let's see how determined you really are. So what is a HoloLens, right? It's this idea of having holograms in your real world. We can have, our favorite characters. We can have game characters. Legendary Entertainment, in fact, had a HoloLens on the red carpet when they released World of Warcraft movie. So you could stand beside the orcs and the wizards and be in the battle scene. It lets you do that kind of stuff and bring that to life in real space, right? But it's also a different way to interact. We use natural language and gestures and speech. One of the things you're going to notice when you develop for HoloLens is that you have a lot more ways to do input and output. You're going to be thinking more like a 3D game developer than a line of business app developer. How many people in here have 3D game dev experience in Unity? Talk to those guys. You're going to need them. But now we can use gestures. Obviously, I talk with my hands quite a bit. But all of us do. We go down the street and to the right. It's about this big, or it's that monitor. And the HoloLens understands that. It also understands what you're looking at, the gaze. And you can talk to it with voice commands. And the voice commands are all entirely application dependent. So you can program the voice commands to do what you want them to do, right? So these new ways of interacting make it very natural. You have something that's sitting here in the real world with you, and you're going to interact with it like you would a real world object. So it's quite a significant advancement in that area, right? Now, when we think about it, the technology is fairly advanced at this point. We've been able to do some things that weren't possible before, which has been pretty slick, right? This device has more computing power than the average laptop. It's fully Windows 10 PC, head-mounted, untethered. So you can actually go into the store icon and download apps to this thing that run on Windows 10, and they will run on the HoloLens, including things like Excel, although I don't know why you'd want to do that. Right? People that have asked that, I say, I know why. I have an idea. You could hang Excel in space and then walk around behind it and see how it works. There's a bunch of little people back there with an abacus moving stuff. But no, in actuality, and we're going to talk about 2D apps in a minute, but what happens is it vanishes. When you walk around behind a two-dimensional application, it disappears. And the reason is, on a PC, there is no concept of depth to an application. There's no concept of a back to it. So there are some things you can do to make your two-dimensional applications volumetric. We'll talk about those in a little bit, okay? Wait, I said I was going to do 2 minutes per slide. I'm running late. Okay, don't worry. So, the world's first fully untethered, self-contained computer, right? Full Windows 10 PC. No need for external wires. Most of the I/O on it, though, is Wi-Fi. So you can do a lot of Wi-Fi communications. Now, because of that, it also means you can contact anything else you can reach on the Wi-Fi network. If you have servers, REST web services, cloud-based whatever, you can access it from HoloLens. Because it runs Windows 10 UWP applications, you have a lot of the .NET framework to work with as well. Okay? There are a few things you will not have that don't make sense in this context. For example, you won't have toast notifications, pop-ups, because that doesn't make sense. As you're walking around and working with objects in your everyday life, you don't have something go boing, oh, you have a message, right? So we don't do that. It might scare the crap out of you, right? Although, come to think of it, it's almost Halloween. Maybe we should do that. The sensor array. Now, this is, those of you who were here last year, you can snooze for about 4 minutes. The sensor array is pretty powerful. There's a bunch of sensors on here. Environment sensing cameras, depth sensing cameras, infrared emitters and sensors, inertial monitors, there's a microphone array, high definition color camera, a bunch of stuff on here. I always think it's funny when people take pictures of these slides. This is on the internet. They just clip it out of the internet. Use Edge, and you can clip your things and mark them up too. If you ever took apart a Kinect, you might recognize some of the layout. And about half the team that worked on Kinect worked on HoloLens. And that's where this grew from. I wouldn't call this Kinect version 3. It's more like Kinect version 20 or on steroids or something. It's a lot more powerful than that. But we also have these transparent lenses. Now, this is a key differentiator between VR and why you might want to consider how you're going to use this. Because the lenses are transparent, it means that you can see through them. You can see the world around you. You can use your PC. You can put things on the podium. You can walk around the building. And most importantly, you don't get motion sick. So I don't know how many demos I've done. It's probably in the thousands now. And no one's gotten sick on me. In fact, I think there was only one person that said she felt uncomfortable, and I found out that's because she took her glasses off before she started using it, which was kind of a bummer. But you can wear this over glasses. So if you wear glasses, that's fine. I've had people, one guy had a glass eye, and it worked fine for him. It did not give him depth perception, but it worked fine for him, right? There are some things we can't fix. But the transparent lenses allow us to stay engaged in this world. It means that we're not, taken away. Whereas VR, if you want someone to have more of a very immersive consumption experience, you're going to want to use VR. You're going to want them to not pay attention to the real world so they can focus on what you want them to see. But if you want to blend things or keep them connected, you might look at something like HoloLens, right? Now, as I mentioned, this is a full Windows 10 PC. It has a motherboard in it. It has a CPU and a GPU and a new chip called the HPU, the holographic processing unit. That holographic processing unit is the thing that processes all that sensor information. It also recreates the surface reconstruction. So if you've seen the meshes, or if you've tried one and gone click and seen triangles go everywhere, that's the surface reconstruction. So as the device is on, it is constantly scanning the environment. And what it's doing is it's building a map of all the physical surfaces that it can see. Now, it is not X-ray, so if I'm looking at it from the whatever you call it, the table, from here, I can't see behind it. I have to walk around it and let the device look. And as I walk around, it will continue to build a map. And then it will remember it. Okay? Now, if something changes behind there, I will have to look again. Because it's not psychic either. That's next year. Don't hold me to that. Don't come back and say, you said it was going to be psychic. Yeah, that's going to be a laughing, running joke. Okay, so the holographic processor was pretty important to getting this thing working. It also improves holographic stabilization. So we don't have as much problem with swim and things moving around, right, because it's dedicated silicone. Passively cooled. There are no fans, which means you're not going to worry about as much battery drain or something on your head going, which would mean you're going to wear it for about 20 seconds before you take it off. So we also have spatial audio. Now, this is an often overlooked feature, but we want to highlight this because if you're going to put digital assets and holograms in the real world with you, you want them to act and sound like they are in the room with you, right? You don't want to break the illusion. And the way we've done the spatial audio, I feel like saying, this is super critical. I just watched Panos Panay, right? This is super critical that you understand this. I'm going to channel my inner Panos. But the audio system is designed so it's not surround sound. It's kind of beyond that. Those of you who have experienced it, if you've come to the demos, I think there's at least 3 of you in here. I always tell people, when you're looking at the sun, walk through it. No, you don't get burnt. Come out the other side and listen to it. Because with your eyes closed, you can always point directly at the sun, wherever you happen to be facing. Because the way the spatial audio system works, it's full 360-degree audio in your environment. We can position holograms up in the corner, and the sound will come from the hologram up in the corner. Whereas surround sound tends to be this 360-degree plane on the level of your ears, right? So if you get to try a HoloLens, or when you get to try a HoloLens, listen to things. Even listen to music. It's pretty good. Now, a lot of people have been asking me this. How much does it cost? Well, that's how much it costs. And 2 weeks ago, it's not on, is it? Okay, good. 2 weeks ago, we released HoloLens with our first wave of international expansion, and we got New Zealand included. So well done. Right? So New Zealand, Australia, France, Germany, Ireland, UK, Canada, and US are where it's available now. You can go online and order it today, and we will start shipping it in late November. I encourage you all to take out your phone and order one right now. That will make me look real good at Corp. So you can order them now. All the information will be on HoloLens.com. Right. So developing for Windows Holographic, and we're doing really good on time, so we're cool. Now, it's Windows Holographic. HoloLens is a device that runs Windows Holographic. When you write applications, you're going to write them for the holographic platform, okay? Everything that runs Windows Holographic is Windows 10. Windows 10 UWPs. So you need to be in that mindset. Think of the Windows 10 UWP APIs you can access, except for notifications and pop-ups, right? That's the stuff you can access. Right? It's one of those things that we're trying to get this thing across a bunch of devices. And our OEM and ODM partners have started making other devices like accessories and new laptops that will include environment sensing cameras for Windows Holographic, which is going to be pretty cool. And if you saw that video, the last video we ran before I started was about Paint 3D. With Paint 3D and these kind of new devices that are coming up that run Windows Holographic, you can create a sketch, it becomes 3D, you save it and import it, and you have a hologram. It takes about 2 minutes to sketch up and create a hologram now. So you might want to get used to Paint 3D. It's kind of cool. All of your existing Windows Universal apps can be made to run on HoloLens. Now, as I mentioned with the Excel example, if you just pluck it out of the air now and you run your 2D apps, they will function, but you're going to have that no back problem. So you might just want to put it up against the wall. It'll run in a two-dimensional window. The Edge browser does, Excel does, right? There are a couple of the ones we've made that we've gone a little further, like Mail and Calendar. We've put the back on them, we've given them a bit of thickness, and we implement a thing called billboarding. Now, if you do make your 2D apps run on HoloLens, at a minimum, I would try to get in there, put it in a frame, and implement billboarding. So what billboarding is I can either do it on demand or real time. As I walk around, the app will pivot to face me all the time. Or if it stays still and you leave it in one plane and walk behind it, you can look at it and say, face me, and it'll turn around. That's billboarding, okay? That way it makes it really easy to reuse those kind of apps and get them in HoloLens quickly if you're going to need them. But since you're writing for Windows 10, you're writing for HoloLens, okay? It's not much of a stretch to take your universal code, common code libraries, add a HoloLens UI to it. A few things you have to shift, though, and we're going to get in those in just a second. So, what are holograms? Now, holograms are literally objects made of light and sound instead of being made from matter. That's the extent of the difference. You want them to look, act, and not feel. Look and act like real-world objects. So that means if you create a holographic ball, and it looks like a beach ball, and it's the size of a beach ball, when you drop it, you don't want it to go pfft. You want it to bounce, right? And fortunately, I'll show you in a minute in Unity, this is not hard to do. Making these kind of things happen isn't hard to do, okay? Now, I gotta make sure I don't forget something important. Yep, got that. Mind, layout, and sound, okay. I had to make some bullet points that, oh, don't forget to tell them this. So, the thing about the holograms is that, along with that real-world object theme, you want to be able to place them anywhere. You want to be able to have them sit on a podium, if it's a solid surface, or the stage. You want to be able to kick it off the stage, if that fits your use case. Make them look and feel like they should be there. Art and visualization is very important when you're creating holographic applications because it's an incredibly visual medium, right? Now, that doesn't mean you can't make things look like cartoons. But if you want to make it look like a cartoon, commit to the style. Make everything look like cartoons. Otherwise, make it look as real as you want. Some of the holographic applications, if you get a HoloLens, you download the Holograms app. Some of them are holographic captures of real people. So we did a 3D model, converted that, and we skinned it with color imagery from the person, so it's near photorealistic. Great, do that. Takes a little more work, but commit to a style. Make it look like it's supposed to be there, okay? So we have these new ways to interact. Gaze, gesture, and voice are the common interaction model for HoloLens. Gaze is what we do every day when we're trying to learn about an environment. When you walked into this auditorium, you looked around. You look for the empty seats. You look for seats and make sure you weren't sitting next to anybody unless you know the person. It's a conference. People do that, right? Everyone wants to sit on the edge of the aisle so they can duck out. I get it. But you learned by looking around. The HoloLens learns by looking around. It uses eyes, effectively, to learn an environment. We did that so that it works like you work. So when you're wearing it and you look at something, it's looking too, and it's understanding the context of what you're looking at. So the gaze is how you're primarily going to track what the user is trying to interact with in your application. And now gaze, we usually track this with cursors. There's a world cursor I'm going to show you in a minute. And that cursor will float around over whatever it happens to hit, holographic or real-world objects. I'll show you how that works in a minute. But think about those things. Make your cursors make sense. If you want a dot for a cursor, that's great. But dots often get lost, right? Like, for example, if I was looking this way and I had a rusty red-colored dot as a cursor, I'm not going to see it on the seats. I will lose it. Even though it should be directly in my line of sight, so I use my head to move my cursor, I'm going to lose it. So think about your cursor designs, right? Now, gestures. I talked a bit about gestures a second ago. But this is a really common mechanism for how we're going to work with things. If you think about moving something, you pick it up and you move it. Now, the gestures are currently built into the OS, and so there are certain ones you're going to use. You're going to like pinch and grab things and move them around. You could even move a car, pinch and move a car. You can like Superman, right? So think about the gestures. Now, people often say, well, can I program my own? Honestly, no, not yet. But that's okay. And it just occurred to me. I have slides for each of these. I should be advancing the slides. We did this one. So for the gestures, you can overload them, right? So for example, a pinch gesture. You can pick up a holographic object and you can move it in real-world space, real-world coordinates. Closer to you, further away, right, left, up, down. You may want to use a different tool, have a toolbar selection. So for example, in one case, you may be playing a stereo and you go like this, volume up. Or in the case of something like Galaxy Explorer, that's zoom, zoom in, zoom out. Tilt, up, down. So think about ways of overloading your gestures by using toolbars. Right? So they select a different tool, you have a slightly different effect for the same gesture. That way you can get a lot of use and varied use out of the same set of gestures. Okay? Now, speech, voice commands. It's a Windows 10 computer. Have I said that yet? I think so. It has Cortana. Ooh. Okay. You can say, hey, Cortana, what's my IP address? And she'll tell you. Right? It has a Cortana voice recognition system in it. Now, the device is currently US English only, so you have to put on your best American accent. I don't know what it is. It's the Nixed and Bic that you guys use that seem to pretend to be a problem. But no, just since it uses the Cortana system for applications, you basically define the XML file, the words you're going to listen for, the structure of the sentence, and the command you want it to execute. If you're not familiar with that, there's a bunch of information on Cortana and bots that you can read up on. But if you spell the word phonetically, right, instead of B-A-C-K, spell it B-I-C-K, it'll understand your accent. You can laugh at that. That was kind of funny. But the voice commands themselves are very natural. It's an easy way to do it. And every demo I've given, people have been pretty impressed that they can say, oh, select and back, and things do, and it responds very quickly. However, there are some cases where people don't like talking to the computer. And I don't know if I'm using a really broad brush here, but it tends to me that it's usually blue-collar workers or industrial workers, factory workers, wellhead workers really don't like talking to the computer. So make sure there's always multiple ways to accomplish what you need the user to do. Gestures and voice, right? And in a minute, we're going to talk about how to enhance each other. Okay, spatial mapping. Spatial mapping is the surface reconstruction. It's how you can actually look around and see the surfaces. Now, these spatial maps that you create can be saved. So if you're creating an application that you know is always going to be done in the same room, that's better, I can see. Go in that room, look around, scan it. Let it build a really good map of that room. Get down on the floor, look in the corners, look at the table legs, the chair legs, anywhere you can. And then save that. Now, when you save that surface reconstruction, you can bring it back to your PC and you can load it in the emulator. So you can get your holographic scenario exactly right. Now, that being said, you don't have to do that. The HoloLens will scan around and recreate the surface reconstruction in real time on the fly. So like when I came in here, some of you saw me walking around over here. I was looking at stuff and tapping on nothing, and I set up some things, right? Because I needed it to get an idea of where the stage was and the chair and where things were, right? Spatial mapping, when you click on the nothing and you see the triangles, that's a representation of it. Now, the map is actually more detailed and more accurate than those triangles are. So you can have a decent amount of faith in it. Okay? Spatial sound. I mentioned this earlier. Please don't overlook the sound. So I mentioned having it sound realistic, but there's another reason you want to pay attention to sound. If you have a lot of holograms or people putting stuff everywhere, they will forget where they put things. And they'll start doing this. Right? But if the hologram makes a sound, chirps, pings, beeps, whatever, they can look straight at it based on the sound it makes from echolocation. So at a bare minimum, don't overlook spatial sound because you need that echolocation capability. Okay? World coordinates. So in VR or in normal applications, everything is relative to itself or relative to a certain predefined point. But what we can do with HoloLens and holographic applications is put things, measure things, and distance things from real-world coordinates, like the corner of this screen. If you place a hologram, you can measure how far away it is from the edge of that screen. Right? So you can do measurements off the spatial reconstruction and with the device. Some people want to code the device strictly for the sensor array and pull information off of that to get measurements or information about the area. That's cool. Use it. We had one group of uni students who bought a couple of them and then knocked the lenses off of it, which made us cringe a little. But they took the lenses off because they don't need the lenses. What they did is they created a sonar system for blind people. So as they walk around, it talks to them and says, object to your left, 4 more paces ahead, turn left, room number 204, turn right, enter. And it basically is a talking sonar. Right? So it's a pretty cool idea. I like the invention. Too bad about the lenses. So world coordinates and being able to measure those things and tell someone when they can turn, how far they can go before they fall off the stage, that's all part of the sensor array and the spatial mapping in combination with world coordinates. So there's ways you can take advantage of that, especially with real-world integration. Okay. Now, where things are laid out, where they're broken up. You guys are going to build everything in that top row. You need to build your shaders and your textures, your models, your materials, your holograms. You need to put those together. Almost all of those, except scripts, is 3D modeling and art skills. A lot of commercial development houses don't have these, and for good reason. Probably haven't needed them before. But if you're going to do holographic applications, like I mentioned, you want it to look like it belongs there or commit to that art style. So you're going to do a lot with 3D modeling, textures, and shaders. Now, the textures is what is like the skin. It's what makes it look like it's there instead of just a wireframe. Shaders give it depth and shadows and things. And those become holograms. Materials are stuff like a highly reflective surface, a dull surface, a satin surface. Scripts is C#. Anybody in here know C#? Well, that's good. So the scripting isn't quite as hard as you might think, right? But getting those art skills, you might have to go and rent them. Right? Now, the Holo Toolkit, we're open sourcing the Holo, well, we have open sourced the Holo Toolkit, but it's basically things that we have found when we've been building these holographic apps that everybody needs. The cursors, the world cursors, right? There's a great example of that. Being able to share a prefabricated hologram, complete with scripts and textures. You drop it in, it's ready to go and sing and dance and do all the things it does, right? Some shaders are in there that help with holographic placement and visualizations in the real world. But those will continue to be open source. We're going to keep piling stuff in there as we learn more and do more and build more stuff. So just watch that, and you'll be able to refresh that. Now, the Windows holographic platform takes care of kind of the tricky stuff. Figuring out gaze, figuring out the gesture input, the Cortana system handling voice, spatial anchors, mapping, and sound. Now, spatial anchors, when you put a hologram in real space, what it does is you say, okay, I want my space shuttle hologram right here. So we set an anchor point. Because the anchor point is, and it depends on how you build your holograms, like in reference to one corner, the other, the center, however you want to do it. But it says that's the anchor point. That anchor point is 35 centimeters from the edge of the stage, 1.5 meters from the edge of the screen, and 25 centimeters from the edge of the black tape. That becomes a spatial anchor and includes an orientation, a facing point. So if you're going to do a multi-user holographic system where multiple people will be viewing the same holograms, what you do is the first person that goes into the application sets the hologram, and that sets the initial anchor point. That anchor point goes to a server that everybody can reach, ideally. The next person that goes in says, has an anchor point been set yet? Yes, as a matter of fact, it has. Here's the anchor point. And then their HoloLens will render the hologram in the same location, the same facing, according to the preset anchor point, so that everybody can see the same hologram in the same space. And you can do this even if they're not in the same room. So the way you would do that is you would do the anchor point relative to the person. So you have the HoloLens. The HoloLens always knows where it is in space and orientation. So you can say it's 1.5 meters at this angle, right about here, set the anchor point. So now that's trickier. That takes some doing, but it's possible. Online, dev.windows.com/holographic, we've got Holographic Academy. And there's a set of tutorials in Holographic Academy. Holograms 240 is multi-user holograms. It's a really good intro to how that thing works and how to get multi-user holograms going. And I recommend you do all the tutorials, actually. And what I'm going to show you in a little bit is one of them. It's the Holograms 101. It shows you a bit about a thing we call origami. So look at those tutorials. And the reason I highlighted the multi-user one is because everybody asks about it. So I wanted to point that out. Okay? You want to see it? Now, what I'm going to do, you're going to see me goofing around up here for a minute while I set this up. And here's where I get in trouble if you tattletale on me. Because if I was to put what I see on the screen and do this, you'd all throw up. Right? Because that screen's going to go whip. So be patient. I'm going to set a couple things up, then I will switch over, okay? And I will try to be as still as possible when I do it. Okay. Which means I'm going to be walking backward and feeling for monitors and things. So this, the application I'm about to show you is the Holograms 101. It's an entry-level holographic application, and we call it origami. And the reason I want to show it to you is simply because of how the thing works, and it's a really easy way to understand some of this. So I'm just getting this set up. Cool. Yeah, that's fine. Now, I realize you can't see anything yet, but that's okay. I'm not going to worry too much about the sound. I'm hearing lovely Japanese-style music right now. It's amazing. So a couple things I want to show you real quick before I actually show you the holograms. This is Unity 3D. Now, this is where you're going to spend most of your time when you write holographic applications. As you can see in here, we have our stage, right? It's got a notepad, a fan, a couple paper airplanes, and these two balls. This are all the holograms and items in the project. I'll turn this down, right? Now we can see that we have, right here, we've got our cursor. Well, the way you make things happen in Unity is you attach a script to it. The way you put sound in something is you attach a sound object, you give it the wave file you want it to play, and there's a little tick box that says Enable Spatial Audio, and then we take care of positioning it in the environment for you. So all of these objects have purposes and things they want to do, right? Like the spheres, for example, which are these paper balls. They'll have a texture. That texture is what makes it look like a blue origami ball or a wadded up piece of newspaper. And then they have scripts, the commands, so I can tell it to do things or I can drop it, right? The sounds. And in this case, I'm not actually playing the sounds on my PC, but when you drop it, it sounds like dropping a paper ball. It goes and rolls around on the floor. So you have to trust me on that one. But this is how everything works. Mesh renderers, right? Sphere colliders. Right? The colliders are what make it contact physical objects. When we build that surface reconstruction, what we're building is a mesh that is a collider. That means it's solid. When you want an object in Unity, there was like 7 or 8 of you that are Unity developers. So if I go too far off track, feel free to correct me. But when you create a model in Unity, you call it a rigid body. And a rigid body means I want physics to act on this thing, right? When physics acts on this, it means that if you tell it to fall, it will drop according to gravity. It will bounce on the floor if you've enabled collisions with the surface reconstruction. And that's all you have to do. It's literally a couple checkboxes. The world cursor, that's the one that came from our open source kit. Now we've discovered that there's a few types of cursors that make a lot of sense or that seem to work better than others. And like a fuzzy dot, not like a 4-pixel dot, but a kind of glowing dot is easy to spot, not too intrusive, and it's easy to place on things. But when it's on something you can interact with, we change it to a donut. Now in this case, the cursor is going to be a red donut. And I'll show you that, except I keep going like this and it keeps shutting the application down. So the origami application is designed to get you across some of this. Now if we look at the cursor, we have this world cursor script over here. If I open up that script, I'm just going to flip over to Visual Studio rather than double-clicking and having opening another version of Visual Studio. We get C# code. Right, this is what's running this thing. Now, the way cursors and the way distance checking and the way a lot of this works is called raycasts. A raycast is literally start here and go out until you run into something. When you run into something, tell me what that is. Right? Now, the thing you run into can say, oh, that's me. You must be talking about me. And if that happens, we can change the cursor. Now, in this one, this line down here, 32 and 33, the quaternion, this will automatically make your cursor adhere to the surface. So it looks like it's sliding along a surface. It automatically rotates it for you. So creating an interactive world-locked cursor that runs over surfaces is actually that simple. That's almost all of the code. Right? Whole thing. Now, update. The HoloLens runs at 60 frames per second, right? Nice visuals. Which means every 1/60th of a second, this will get called to continuously update its position to make sure it's in the right place. When you're thinking about developing holographic applications, developing in Unity, you need to think on these 60 times a second cycles. Now you can imagine if you're doing something fairly complex, every time that comes around, you're going to really start draining on the processors and the systems and the battery. So you need to think about efficient coding. The ideal skill set so far for holographic development is 3D mobile gaming. You're used to low battery consumption, low CPU consumption, being friendly with the network. using low polygon models, being very efficient with your 60 frames, well, in the case of a phone, like a 30 frame a second model. So think that way. Think along these really efficient lines, okay? All right. For a second I was going, wait a minute, did I have any of that on the screen? But I did. Okay, now I'm going to start this up, and I'm going to hook in the video streaming. And then I will switch over and try to be very still and very kind to you. Okay. You can see this little thing moving around. I'm going to try to make sure that, oh boy. Okay, ready? I'm going to try to not move too much. What you see in front of me is that application is a hologram. You can see the red circle, right? It moves around and adheres to the various objects. It changes to face them automatically just by using that quaternarian thing. You can see our spheres. Now our spheres are voice controlled as well as cursor controlled. I can use a gesture or a voice command. Okay. I can even reposition these in real world space. Okay, bear with me. Now you're going to see a bit of a lag on the screen. Okay. Now as I moved that, you saw those triangles show up. That's the visualization of the surface reconstruction. See those triangles? Trying to move slow enough so everybody doesn't get rid of lunch. Okay? Now, one of the things I want you to notice real quick is that I've got these boards here on the floor, that chair over there. What I do with that is I give the HoloLens something to visually hang on to. If you have a pure black or pure white room, it won't work. And the reason it doesn't work is because it has the same issue your eyes do. If you were in a VR cave, which is essentially kind of a roundish room with curved ceilings and floors, when you stand in the middle of it, you can't tell how far away the wall is because you have nothing to visually scale it against. The HoloLens won't know either. So in a pure black carpet like this, it was working pretty well, but I added those boards just to make sure that the holograms are very solid. Okay? So bear with me on this. I can walk around and that hologram is there on the floor in real space. And I can try to not walk off the edge of the stage, which is a real danger. Nobody's getting sick, are they? Because if you get sick, I'm going to snap my head up to look, and then everybody's going to get sick. Okay. Interaction. First, I'll show you the interaction with gestures. Actually, gesture or voice? What do you want to see? Voice? Drop. Drop me. Oh, I forgot what the voice command was. Drop, die, go, whatever. Now we have an issue. I wonder if our insurance would cover this. Don't get sick. Of course, the more you talk about it, the more you want to, isn't it? Now, you want to see something cool? Reset world. That's not the cool part. Okay, hang in there, guys. Hang in there. Oh, there's our paper ball. Okay. Reset world. Okay. Nobody threw up. Thank you. All right. Wow, that looks kind of funny from this angle now. So, that's just using the app. You guys, do I have a red mark on my head? I want to write HoloLens backwards on the inside of that headband. So every time I give somebody a demo, they walk around with HoloLens on their head. Okay. So, building 2D or 3D apps for HoloLens. Now, the 2D apps are the ones we talked about. And I've only got 18 slides left to go. No, I'm kidding. You can do 2D projections. Sorry, that top one over here, Bing and Edge, that's like a 2D application and that's built into the device. It comes with Windows 10. You can hang Edge on the wall, hang it in space, and still use it. It works fine. In fact, if you're a Netflix fan, put Edge up there, stretch it way out, and watch Netflix. Sounds really good, too. Again, standard UWP. You'll build your standard 2D apps with UWPs. You can deploy them, but you can still go beyond a screen. So now you can take your existing Windows 10 apps, and you don't have to have them on a PC. If you use them in HoloLens, you can take your existing KPI dashboard or something else just as exciting and pin it to a wall or have it float around beside you. You can have a Skype call as you're walking around the building. Right? So you're not going to have to waste your existing efforts, right? You can reuse most of it. Sorry. The other thing is, now, if you add some voice commands, all of a sudden your 2D app, you have hands-free computing. We had one guy, that's all he wanted. He worked for an insurance company, and worked with insurance adjusters. And he had this little problem. After a storm, all of his insurance adjusters would go out, put the ladder up, climb up on the roof, and take pictures of the damage of people's houses. And because they were using the camera, they would fall off the frickin' ladder. And all he wanted to do was have a hands-free camera, voice-operated camera, to keep people from falling off the ladder so he can have two hands on the ladder. Sure, go for it. So you have this idea of instantly getting this hands-free computing for your applications. Now, holographic apps, they are 3D to the core. You need to think about outside in and placement and what it's going to look like if somebody walks around it. You need to think about things like clipping planes. If you have a holographic application or hologram and you get too close to it, people are going to go cross-eyed trying to look at it. It's like same thing with your finger, right? There's a distance at which holograms are comfortable. Our research has said it's about 2 meters. It's a comfortable distance. You can look at things closer, but I wouldn't get it any less than, say, 18 centimeters from your face. It starts getting too close. But how's that going to affect your situation? Do you need someone to get right up into a texture and look at it? Is it geological data? Maybe. So, be judicious about that. Now, it says you can use C++, DirectX, or Unity. All true. In fact, when you set up applications, let me really quickly switch over to Unity again. I want to show you something. When you do the build settings, you go in here and you do build settings, you switch it over to Windows Store, and I can't make the Unity window any bigger. Universal 10, Direct 3D. So you switch over from XAML to D3D. And you add C# projects. Unity builds that and hands it off to Visual Studio for packaging, right? So you use Direct 3D under the covers anyway. You can write it directly in C++ and DirectX if you are a masochist. It's just harder. Now, like anything, right? You've got C# and .NET that's easy and soft and cushy to work with. Then you have C++, an assembly language where you can shoot yourself in the foot really easy. So move your slider, wherever you're comfortable with, you can use, okay? The Unity system and adding behaviors and taking advantage of the existing platform features is an incredibly powerful platform. You can do some amazing things with it. All the applications you've seen from us, including the RoboRaid game and the Galaxy app and Skype, was all done in Unity. The other cool thing about this is that you can use an entirely free tool set. You do have to put up with some splash screens. Like if you download the version of Unity, you can say it's personal use. You can use that. But when you start your app, it'll say, made with Unity 3D Personal Edition. And you have to wait for the splash screen. You can use the Community Edition of Visual Studio as your code editor and to package up your applications. If you want to create 3D models, and you don't want to use Paint 3D, you can use things like Blender, which is an open source 3D modeling tool. The formats are standard. OBJs, 3DS formats, everything is standard about the application, about the development. Everything is C# or C++, standard coding, standard .NET mechanisms. Everything is things you're already familiar with, or you can buy graphics, right? But there is a tricky part to creating these applications, and that's the design. Design is hard. No, it's not hard, it's tricky. Holographic water bottle. I set my holographic water bottle carefully on the corner of my physical screen. Have my HoloLens on. Now, while I have it on, I'm looking at my water bottle. Everything's very nice and happy. I go in the back. While I'm gone, they come out and they take the screen away. When I come back on stage, what happens to the water bottle? Still there? Falls? Maybe? Yeah. Who cares? No, I'm kidding. No. These are the decisions you have to make. You could leave it floating in space. Absolutely, you could make it float in space right there. Don't do that. It breaks the illusion. You could make it fall, and it would act just like that. Right? Of course, you don't want to trip on it. No. But to be honest, there's an easier way to handle it. You don't display it. And your explanation is, when they took the screen away, they took the bottle with it. Right? So it's an easy way to explain that, and it's an easy way to handle it. Don't overthink this stuff. You're using holograms made of light. To make something out of light, you put light into it. Right? How do you make black? You take light away. And if you've taken the light away, you've taken the hologram away. So you can't use pure black for holograms. Right? These are the things you're going to spend some time thinking about. These are the hard things, the tricky things. This is usually where I tell customers about our Enterprise Acceleration Program, where you can hire us to help build your stuff. Yeah. But we have a great set of forums, right? Our teams watch those forums regularly and are pretty quick to answer questions if you ask a question on those forums. Right? So, get the emulator. We actually used the emulator for all of our teams spread out around the world when we were building HoloLens and our sample apps and writing core code for it. So when the emulator wouldn't do something, well, we worked on the emulator first, and then we went back to doing what we were doing. Oh, let's fix the emulator. The emulator is really good, really, really good. So don't be afraid to use the emulator. If you have something that runs in the emulator, it'll run on HoloLens. The difference is you can't see the real world through the emulator. It's black. And everything that's black is transparent. So what you see as black in the emulator will be the real world when you're actually running your application. Okay? Now, if you're only going to stick with 2D apps and put them in HoloLens, you don't need Unity. You can still use Visual Studio, code them up, whatever, package them, and deploy them. And if you go to the Windows Store right now, I think there's about 35 apps in there directly for HoloLens now. You just have to tell it one of the UIs. Like when you submit your package, you say, oh, this is tablet, desktop form factor. Tick HoloLens as well. Okay, there you go. It'll show up on the HoloLens list. Okay. Build. Build, experiment, try, fail, rebuild. Do it some more. Ask questions. No joke. The community around this is really exciting right now. People are really pumped up for holographic computing and 3D and all this stuff. There's a massive movement behind this thing. Go ask. Go do it. Right? The forums on .hololens.com is an awesome place to learn a bunch of this stuff. Okay? Now, don't jump up just yet. First, I have to show you the logo slide. No, I'm kidding. This. Don't forget this, because when you win that, I'll take it from you. No. But don't forget, all of your evals do go into the drawing for a Xbox One S, and Xbox One S. And I know you guys are going, dude, shut the hell up, party's starting. I got to go. I got to get dressed up. So I am happy to take questions. Stage is yours. Thanks. Thank you. I don't know if we have mics, so I'll try to repeat the question. Right. So the question is, can you hook the emulator to a webcam or something so you could project the background as the real world? Yes, but you'd have to get in the guts of the emulator yourself. By default, it doesn't do that because of the way the camera works. What was that? Feature request? Stay tuned. Watch that space. That's a great question. Does the HoloLens have light detection so you can make the shadows realistic according to the ambient light? That good paraphrasing? Okay. Yes, it has an ambient light sensor. However, you have to have the code that will say that's a light source, and then in Unity, you generate game objects as point light sources in generally the same location, and it will create shadows for you. But you have to code that. Yeah?
Anything that's in Unity that's not supported?
Anything in Unity that's not supported? Not too much, actually. Most of it is. I haven't run into anything yet, but then again, I haven't done a lot of advanced programming yet either with it. If you do run into something, rockyh@microsoft.com, let me know. But I think you can use almost all of it. I'd be careful with a lot of high poly count post-rendering, though. That's going to drain battery and CPU. Spatial sound. It doesn't by default, no, because that might not be appropriate. And if we did it automatically for you, we'd probably screw some things up you didn't want screwed up. So we let you handle that. If your spatial mesh and your spatial map is huge and you say, look, the walls are like this, or far apart, in code, you can actually tweak it and put a reverb in the sound as you go. So you can handle it in code, but we don't do it automatically. Yeah.
How does it get on if you're long-sighted and you can only read books that are right here, but you've got a lens like 2 inches in space?
Actually, the way the lenses are designed, the holograms will still be at 2 meters. And if you have fine text on them, you may need to wear your glasses underneath the HoloLens. But it puts them in real space at real distance, so whatever. Well, yeah, they aren't, but they are. The way it works is we use your interpupillary distance, which is the distance between your eyes, to place holograms out in space at a real distance and a real focal point. So it should be correct for your eyes to focus at 2 meters, 2.5 meters. So if you need glasses to see at 2 meters, wear the glasses under the HoloLens. You might have to try it. I need longer arms to read now, and so it works for me. If I'm reading something on HoloLens, I got to move it back. But you want to know, here's a cool trick, little tip for you. The HoloLens has issues with mirrors. It's a visual thing, and it has an understanding of mirrors about the same as a 3 or 4-year-old child does. If you sit a kid in front of a mirror and they look in the mirror, they go, oh, hi, bang, what the fuck, right? The HoloLens think that too. If I was in a very tiny hotel room. Now, I was trying to do some coding, but I had to back up. So I looked in the mirror, and it appeared behind me, so I doubled my distance. It works really well. So for visually, it's the same kind of thing. It will put it out at distance. So if you need to focus that far away to see it, then you'll still have to do that. Sorry, that was a sideline. It's fairly comfortable. It's balanced over your ears, so you don't have that whole VR neck strain thing happening. But actually, you wore it for a while. What did you think? Comfortable? I've worn it for up to 5 hours at a time.
So more like it's more of a hypothetical sort of thing, but with all the Wi-Fi, Bluetooth?
Yeah, Bluetooth LE.
around your skull all day long, electromagnetic. Has it been
Cell phone.
Yeah, I know, but cell phone is like
To be honest, the billions of research dollars going into that stuff, the jury's still out on it. I used to work in aircraft and aviation electronics and radars and things. And if you could actually visualize the amount of RF energy already going through your head, you wouldn't be able to see 6 inches in front of your face because of all the RF energy. Now, admittedly, having one right here, turned up full power on a Wi-Fi signal, I don't know. Jury's out. Yeah. Yeah. Oh, that's a great question. So, difference between enterprise and developer, the hardware is exactly the same. The difference is in the enterprise features. So, for example, the enterprise suite, commercial suite, comes with a warranty. DevKit does not. You can put it in kiosk mode, the enterprise suite. You can put it in kiosk mode. You can manage it with MDM. You can encrypt it. You can do all the things you would do with a commercial device, right? Control it, manage it, care for it, feed it. The dev kit is a rogue on its own. You get the device, you go for it, and that's kind of it. Yeah. So on the back of the box, we say 2 to 3 hours of average use. But your mileage will vary. It depends on what you're doing with it. If you have a lot of light points, so, like you're doing some kind of 360 video and there's a lot of light being generated and there's complex polygons being rendered, lower. If you're doing something like origami or the space one where there's not a lot of light and it's fairly contained, longer. The device is charged via USB, micro USB, so you can connect a power cord or a battery pack to it and extend that, but it will outrun the charger. Eventually it will run the battery down faster than it can be charged. So my marathon time, and don't quote me on this, was 5.5 hours, and I didn't actually flatten the battery. Yeah. Yes. Okay. So the question was, it was a Windows 10 PC that's in there. Does that mean it receives Windows 10 updates and feature updates and things? Yes, it does. Yeah. And every once in a while, I'll say, oh, we need to restart your device for an update. And then you go, not before a demo, man. Yeah. That's a really good question. Next. No. So it has an infrared pickup. It won't, and I'm kind of speculating, so you should go investigate this for yourselves, but it won't pick up absolute temperature. It picks up relative temperature differential. So it can tell that bodies are hotter than empty chairs, for example, but it can't say, oh, that's 22 degrees Celsius or something like that. So I wouldn't go there. Just, yeah, I don't think it'd be a very exciting trip.
How about the light temperatures, like the color light? So if it has a really yellow light or red sunlight, would the hologram adjust the color temperature according to the environment we're using?
It doesn't automatically. You would have to code that based on the ambient light sensor and what kind of thing you're seeing. The thing is, colored light, it's a furphy. You can have a white fluorescent light that appears very bright and stark to the eyes, but is very cool in general. And by the same token, you can have a very low, dark infrared light that is ridiculously hot. So it's really difficult to match that kind of stuff anyway. But hey, if you figure out how to do it, give me a call. There was one, yeah. Do Microsoft have any plans of integrating HoloLens with Xbox in Xbox development? We have nothing to share at this time. And to be honest, they don't always share that with plebs like me. But I can say from some experimentation that if you have a Windows PC and you install the remote desktop app and your Windows PC is doing Xbox streaming, works a treat. What else? Yeah.
Is there any support in the SDK for recognizing and mapping people, the types of movements they make in augmenting reality on people?
is there any support in the SDK for recognizing people and being able to augment overlays on people? No, but there's a reason. I'll give you the reason. Let's say you have a hologram and you've got the surface reconstruction here, and you're looking at this hologram, and people refuse to accept holographic etiquette, and they walk in front of you. If they did that, your hologram would go whip, 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 and that would be a terrible experience. So while the surface reconstruction is being done in real time, there is an intentional delay before we call it healing, before we heal the SR and start positioning holograms on it. Because of that characteristic, we don't track fast-moving objects. We try to ignore them to stabilize holograms. So you really can't put a hologram on a moving object. Now, if the person stood there for 2 seconds, sure, pin everything you want to them. But as soon as they do this, they'll go whoop, 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 right? Next. We are always trying to make it better, faster, stronger, cheaper, and it's not like we haven't heard that before. But the holographic frame is intentionally designed to preserve your peripheral vision. Because if it didn't, and you had a fairly immersive experience, you're going to run into stuff as you walk around. You can't see people, and we don't want that effect yet. Does that mean it won't get bigger? It might. The engineering team is working on stuff for a long time. I'll give you an example. We've been working on this device for over 6.5 years, almost 7 years. So in 2009, they started building this thing, designing and building it. So you can imagine this thing was originated like 9 years ago, a few changes, came out January of 2015. So imagine what they're working on now. It's going to come out in 3, 4, 5, 6 years. I said imagine. I'm not going to tell you. Well, here I'm acting like I know. HoloLens was one of the best kept secrets in IT. It was amazing. Nobody in Microsoft even knew it was happening. Absolutely. Just holograms? Or yeah. Yeah. So that's good. The overall question is basically, is there a repository where you'll be able to put holograms that other people will be able to access and pull down and look at? Yeah, kind of. So if you saw that video I showed in the very beginning, that 3D paint thing, all those 3D creations you can make in Paint are effectively being compiled and built as holograms and 3D models. There is a repository for those. So if you put your 3D models in there, you'll be able to download it from that repository and use them as a hologram and decorate your room or your environment with the holograms from other people. That extending directly to HoloLens and using something like Blender to create a hologram and putting it in Unity and giving it life and feeling, and then into there, I don't think that chain has been put together yet, but the one from 3D Paint has, but those tend to be static, right? So I have a feeling, and this is pure speculation on my part, this is not an announcement or a quote, that eventually we're going to see them converge. And just like the Unity Asset Store, yeah. But I would start with the Unity Asset Store. Did we empty the, oh. So there's roughly 180 and 120 degree view, basically anywhere in front of the device. I tend to be lazy. I tend to do it down here. It's just comfortable for my shoulder and elbow. So you put the cursor on the thing you want to interact with, and you tap. Right? Now this doesn't work. This doesn't work. I've seen a lot of people that they try an experience and they reach out and try to tap on the thing. And no, back here. Then they'll go like this. And no, down here. Right? So you have to get used to it. Now, when you first do an out-of-box experience with the HoloLens, it takes you through that, and it shows you where that stuff is. It says, okay, put the ready gesture, and it goes red, green, and it basically shows you where that layout is and where that area is when you start it. Ooh. Do you guys know the magic number? How many of you heard me talk about it? There's a magic number for speakers. It's 8. The magic number is 8. If you can be in front of an audience and say, is there any more questions? You start counting. 1, 2, 3. If you can get to 8, 7 is an uncomfortable silence. And if someone has a question, they will fill that silence by 7. If you can get to 8, we're pretty much done. So that's 9, 10, 11. Thank you very much for coming. Enjoy the party.